Hello, my name is Nate, and this is the third video in a series I'm calling How to Get Started with Prefect. And in this one, I'll be touching on task mechanics. So basically, tasks in Prefect are atomic pieces of work that are basically just Python functions with some bells and whistles that are useful. So I'll talk about submit, which is how to create one future that you eventually wait or resolve. And then map, which is doing submit for an entire list of inputs or iterable. And then prefix future list methods are just syntactic sugar for like common patterns like for loops and list comprehensions that are just clutter if you're just trying to do something simple and you don't need extra control. And then retries and how you can selectively retry based on runtime values. And then creating artifacts that can sometimes be useful just as a bonus feature. Okay, so let's start with just using tasks. How do we define them? Oh, first of all, let's get a Python environment. So I have Python 3.12, I think. Let's see. Um, in a virtual environment where I have Prefect installed, o.10. And yeah, Python 3.12. And I'm running against an open source server that I started with this command, which is an image built from main, but you could instead say prefect HQ, prefect with the three latest tag, for example, and add like a Python version if you want all that. But in this case, I just already have my container up. So let's say from prefect import task to get ourselves the task decorator. And let's just take a simple function to start. We'll say like we have some integers that we want to double. So we'll return x times 2. Cool. And so we can just normally call this function, like for example, use calling 4. We get 8 as we would expect. But what's cool about prefect is that if you're in a flow, you can sort of just map this task or submit it to run concurrently. So we'll do the submit syntax first because it offers you more control and it's probably consistent with stuff you've seen before. Um, so we'll say we have some list of futures that we want to populate. So let's say doubled futures, and then we'll say for I in some range. Let's say that doubled futures, we're going to append a future that we submit. And then we have this list of futures that we can say that the doubled actual results are what you get if you call dot result on each future in that list. So we can go ahead and print this saying doubled, and then we can go to the top to say that we want to send our print statements to the Prefect API as info level logs. And so now we should be able to, from prefect import flow. Um, Now we should be able to run this. And we should see that we did double our numbers and we get this run in the UI that's here. A bunch of stuff happened. But there's no dependencies because those are just a set of tasks that ran concurrently. Um, so we can just write this much more simply if we use map and we don't need the extra control of appending the futures ourselves. So we can just say from or print double dot map over the range and then collect the results with this dot result method on the entire list of futures, which you can also use dot wait if you don't need the results. And just as a note, you'll notice that if I take off the dot result and I run this again and I don't return these futures, we'll see that workflow starts to throw these weird errors about garbage collection. And the deal is that if you're not returning them or otherwise passing them to a task, they're not being consumed. And so you're not necessarily waiting for those features to resolve before you exit the scope. So when we exit the scope of the flow, we garbage collect, or Python garbage collects those features. In Prefect 2, we would look for cases like this and do it for you, but in general, that's not how normal concurrent features work. So we've decided to make the author explicitly um, call dot result or dot wait on those features. Okay, so this is sort of in general how you can use these methods, but like let's look at some more real looking code. Um, in this case, what I have is a simple little flow that tracks the current astronauts in space. And the way it does that, it uses this like nice little free service, which just gives me who's in space and on what craft. So I grab all those astronauts, And then I enrich the astronaut data from a Wikipedia API, which you could just mentally replace with any sort of concurrent processing you would want to do on some lists or on some inputs that you got from some IO call. So in general, this could map onto a lot of high-level APIs of workflows, if you will. Um, and so what we're doing actually for each astronaut that we get from that API is enriching it by making an API called Wikipedia, and we'll go ahead and build this dictionary or like a row in a table for that astronaut. And notice that we have a cache policy, which is saying that if we pass this set of inputs again to the same task, we should just return um, the result because we already found it and we cached it someplace on disk. So we should just be able to use that without running the Python function again. And if you wanted to invalidate that after some time, you can say that cache expiration is some time delta. But for now, I'm not going to do that. So now that we've mapped each uh, enrich astronaut task. We now have a list of dictionaries because each map task produces a dictionary. And this list of dictionaries is basically just a table that we can save as a table artifact. Artifacts in general are things that have keys that you might want to save and render in the UI. And in this case, if I want a table, I'll pass a list of dictionaries with a image description, which is a meme I made about sort of the Zen of Prefect. So let's go back. Let's run this flow now. Um, and we should see is that we get this run URL, which I'll pop open, and we get all the current astronauts, and then we fan out and enrich the astronaut data for each astronaut that we found using threads. With the default task runner for prefix flows is to use a thread pool executor to do each task in a thread. So that's important sometimes if you have like a database client. You might not want to pass a client between threads in some cases. But ultimately, what we see is that the fan out fans back in to the save astronaut data task, and that produces our artifact with our nice tables, Oleg, Nikolai, Tracy, all those fellas and gals in space. Um, cool. So we have artifacts that were produced by making some IO call, doing some concurrent work on the results of that IO call, and then arranging it in some way that's useful for our human brains. Um, and hopefully, last thing I'll cover is the quargs that I'm using here for this IO call, which in this case is to make this get the astronauts. I'm saying that we should retry 42 times, which is kind of silly, but let's change it to three. And I'm saying that each time we fail for some reason, API goes down, we should wait 30 seconds before retrying. But we could also say that instead we want to retry after 3 seconds the first time, then 4 seconds the next, and then 30 seconds. And say that we have 42 retries. In this case, every time after the third one, we would just continue waiting 30 seconds up until 42. So that's how that works. And then we can, in addition, if we want, stipulate that we should only retry if some condition is true about our runtime values. So in this case, if the result associated with our state of our task is an exception that has a status code of 429, then we'll retry. Otherwise, we won't retry. So this is only retrying on rate limiting, which is perhaps dangerous, but hopefully this illustrates how you can use this for whatever type of error you need to check for. So yeah, this is how it all fits together. And I hope that this was a useful summary of some of the ideas that I wanted to talk about here. And I will see you in the next one.